At a time when the development of shipbuilding in Europe was focused on sailing ships and early steam vessels, a concept for a craft emerged in one country, capable not only of moving on the surface of the water, but also submerging beneath it. At that time, the term submarine was often associated with technical impossibility. However, in this empire, despite the accompanying difficulties, a decision was made to continue work in this direction. It was on the banks of the Neva River in one of its workshops that work began on a project which made this country one of the first to successfully submerge an underwater craft. This occurred in 1834 when engineer Karl Andreevich Schilder, serving in the engineering corps, presented the craft's design. This structure, made of metal, had an innovative design for its era. It had no engine and did not use electricity. Movement was provided by the physical strength of 12 sailors and controlled by 2 commanders. Externally, the craft had a streamlined shape, while its internal space was confined and demanded significant effort from the crew. This craft demonstrated the feasibility of a metal vessel operating underwater. Schilder developed a system where human strength was used as an integrated component of the propulsion mechanism. The crew propelled the screws by rotating hand cranks. The craft's hull withstood external water pressure. Tests were conducted in the Gulf of Finland, where the craft submerged and remained underwater for 3 hours. This result was significant for that period. The primary goal of the invention was not only the ability to submerge, but also the capacity to attack an adversary from a stealthy position. According to the engineer's design, the underwater craft could covertly approach enemy ships and attack them with mines. This idea was perceived as groundbreaking. Schilder, however, believed that such an approach, sudden, underwater, and precise, would become an important element of future warfare. He proposed using the craft for coastal defense, specifically for the defense of Kronstadt and Petersburg. Crew members involved in the trials noted that it was dark and stuffy inside the craft, but they understood the significance of their participation in developing a new type of weaponry. Every action of the crew underwater was considered a significant step in technological development. The craft moved slowly but steadily. Its metal hull produced sounds, and rare air bubbles appeared on the surface, indicating the craft's underwater position. Despite the demonstration of its functionality, many contemporaries viewed the invention skeptically. The relevant department was not quick to adopt the craft into service, citing its novelty, the boldness of its concept, and its high cost. However, Schilder continued to work on the project. He refined the design, incorporating signal tubes for communication, a ventilation system, and also proposed placing the first rockets on board, which was innovative for the 19th century. He proposed launching rockets from underwater, which gave the craft the capability for stealth attack. Although this idea was perceived as radical even among military engineers, its emergence testified to the progressive nature of engineering thought. Soon, in St. Petersburg, Schilder became known as an inventor ahead of his time. His project became a subject of study in engineering schools, and his blueprints were analyzed by young specialists. For some contemporaries, this apparatus was perceived as a demonstration of the empire's technical potential. Schilder's apparatus was massive, with limited maneuverability and reliant on the crew's physical strength. However, its concept demonstrated the boldness of engineering thought. This invention paved the way for further developments in the field of underwater shipbuilding. After a series of dives, when the apparatus was returned to shore, dents and traces of corrosion were observed on its hull, but the structural integrity of the design was maintained. The apparatus successfully functioned in challenging conditions, which was regarded as a success. This event sparked prolonged discussions in St. Petersburg society. The press mentioned an apparatus developed in Russia that submerged underwater. Some observers expressed skepticism regarding its practical value, calling the underwater apparatus a toy. Others considered it a significant achievement, heralding a new phase in the development of naval military technologies. While engineers in other countries considered the possibility of underwater navigation, the first apparatus of this type was launched in St. Petersburg, demonstrating the possibility of functioning at depth. Upon completion of the tests, Schilder recognized the need for further developments. The state was only beginning to explore underwater technologies, but it was his work that initiated a chain of events leading to the emergence of full-fledged combat underwater vehicles equipped with engines, torpedoes, and pneumatic systems. From this moment, the systematic exploration of underwater space began. Decades of research, development, and practical implementation lay ahead. 30 years later, another Russian engineer continued these works and created a submarine which gained renown in the 19th century. This was Alexandrovsky, whose name is associated with a new stage in the history of the development of the Russian submarine fleet. In the mid-1860s of the 19th century, Russia entered a new phase of its technical development. The state, recovering after a period of reforms, showed increasing interest in modern machinery and mechanisms. The Naval Ministry initiated the development of devices capable of providing the fleet with a tactical advantage. During this period, Ivan Fyodorovich Alexandrovsky emerged, whose name is noted in the history of Russian underwater technology. Alexandrovsky possessed diverse engineering and scientific training, as well as experience in naval service. He proceeded from the premise that to create a strong fleet, it was necessary not only to build ironclads, but also to develop technologies enabling covert operations. In the year 1866, he presented a submarine project, the design of which proposed significant improvements compared to existing analogs. The core of the design consisted of pneumatic engines powered by compressed air, stored in 200 cast iron cylinders. This technical solution was groundbreaking. The use of compressed air provided propulsion and allowed the apparatus to remain underwater significantly longer than its predecessors. The submarine, with a displacement of approximately 350 metric tons, could submerge and move underwater for an extended period. It was equipped with two engines with a combined power of 117 horsepower, which was a significant figure for that period. The crew consisted of 22 people, who not only had to operate complex machinery, but also work in confined spaces. In the same year, the submarine was launched. In St. Petersburg, the event was met with interest, but also with a degree of caution. The underwater vessel was still perceived as innovative and associated with risks. Tests began under the supervision of the fleet and representatives of the Naval Ministry. Alexandrovsky personally controlled every element, from the cylinder systems to the valves responsible for pressure regulation. The results of the initial trials showed successful results. The submarine submerged and surfaced confidently, demonstrating maneuverability. Its hull withstood significant hydrostatic pressure. Inside, a pulsation from the pneumatic engines could be felt, a steady, characteristic rhythm. The sailors quickly mastered the new mechanisms and began practicing coordination in emergency situations. For that time, this was in line with leading global developments. Further operation of the submarine underwent changes in 1871, when adjustments were made to the command staff. A new team was formed to conduct a series of control trials, including diving to the maximum depth. During the same period, a hull strength test was performed without a crew at the York Sandy Proving Ground. The apparatus was lowered to a depth of 24 meters, which at that time was considered a depth requiring increased safety measures. The structure withstood the water pressure and surfaced without visible damage. The test result confirmed the correctness of the engineering calculations. After the successful completion of the first trial, Alexandrovsky decided to conduct a repeat experiment with increased depth. On July 30th, the apparatus was submerged again to a depth of 30 meters. Initially, the process proceeded as expected. valves functioned, and pressure stabilized. However, after a few minutes, the steel sheets of the hull began to deform. An intense hum arose inside the hull. Shortly thereafter, the hull suffered destruction. Under the influence of water pressure, the apparatus underwent critical deformation. The test concluded with the destruction of the apparatus. The apparatus was completely destroyed. Despite the destruction, Alexandrovsky initiated actions for its further study and possible restoration. He obtained permission to raise the hull, and 2 years later, in 1873, the apparatus was recovered from the water. Despite the damage sustained, the engineer presented proposals for restoring the structure. He proposed to modernize the apparatus, lengthen the hull by 10 feet, and reinforce its walls. However, the Commission deemed the repair impractical. The project was suspended. The apparatus was placed in a floating dock for several months, after which it was moved to the veiling of the new Admiralty. There it became an object of study for young officers and designers. Alexandrovsky continued to work on the concept. He compiled reports, developed schematics, and advocated for the need to continue the development of submarines. However, further developments took a different turn. The engineer passed away in 1896, not living to see the resumption of work on his concept. 5 years later, in 1901, his apparatus was dismantled for scrap metal. At this stage, the project could have been considered complete. However, the experience and information related to the project were preserved among the specialists who observed the apparatus's functioning. Alexandrovsky's work demonstrated the practical feasibility of underwater navigation, based on engineering calculations and not solely on theoretical assumptions. His ideas served as the foundation for a subsequent generation of engineers. Soon after, engineer Stepan Karlovich Jvetsky continued the development in this direction. He designed a series of small submersibles which became the first mass-produced models of this class in Russia. These apparatuses were characterized by a simpler design. Their appearance marked a new stage when submarines began to be integrated into the Empire's system of port defense and strategic planning. After the completion of Alexandrovsky's project, interest in the development of underwater technologies in Russia persisted. The experience gained was recognized as valuable. The engineering community concluded that a submarine was a reality requiring precise calculation and discipline in its development. Subsequently, Stepan Karlovich Jvetsky initiated the transition from individual experiments to systematic development. He represented a generation of engineers whose work was based on the experience of their predecessors. Jvetsky's design approach did not involve the creation of large vessels. Instead, the emphasis was placed on compactness and reliability. Unlike Alexandrovsky's large and technically complex apparatus, Jvetsky's designs became the first stage in the creation of a mass-produced submarine fleet intended for practical defense tasks. In the early 1880s, he presented to the Naval Department a project for a small submarine capable of moving underwater by the muscular strength of its crew. The design was characterized by simplicity. One crew member steered, another rotated the propeller shaft, and a third controlled the ballast system. Despite its apparent simplicity, this solution was recognized as its key advantage. These advantages included a minimum of complex mechanisms, reliability, and ease of repair and operation. A 3-person crew could submerge and perform tasks in coastal areas, remaining underwater for up to 50 hours. The presented time indicators for that period were significant. The armament consisted of 2 mines designed to be attached to an enemy's hull. At that time, this was considered an effective offensive means, given that most navies of other states were only beginning similar developments. The first submarine designed by Jvetsky was built in 1881. Trials demonstrated positive results. The vessel was steerable, submerged, and showed stability even in rough seas. A key feature was the hull's watertightness, ensuring the crew's safety at depth. The submarine proved to be sufficiently effective, which prompted the Naval Ministry to decide on building a series of similar apparatuses. Thus, Russia obtained its first mass-produced submarines. They began to be used in the port defense system in the Baltic and Black Seas. These small apparatuses patrolled waterways, controlled harbor entrances, and could launch a covert strike in case of a threat. The submarine fleet transitioned from the experimental stage into a component of military strategy. Each new generation of boats designed by Jvetsky demonstrated improved characteristics. After the initial trials, he implemented a series of improvements. The propulsion mechanism was modified, the capacity of the tanks was increased, and a new ventilation system was developed. Concurrently, he engaged in theoretical calculations, aiming to enhance the safety and predictability of underwater navigation. His designs garnered interest not only in Russia, but also abroad. By the late 1880s, submarines of Jvetsky's design were already in service in several ports. They were not deployed in the open sea, instead functioning as patrol vessels guarding approaches to strategically important sites. The main achievement was that Russia became the first country where submarines were mass-produced and integrated into the defense system. Military specialists noted the reliability of the design and the simplicity of operation. Sailors serving on these boats reported that adapting to them did not present significant difficulties, but working underwater demanded a high degree of endurance. Each descent was a test, and each ascent was perceived as the successful completion of a stage. In the confined space, the crew formed a unified team, where each member understood the importance of precise actions. After modernization, Jvetsky's vessels gained the capability not only to remain submerged for extended periods, but also to make short surface transits, which increased their operational flexibility. They were employed during the Russo-Japanese War, when Russia first used submarines in actual combat conditions. Despite their limited role, the participation of submarines confirmed the viability of the concepts developed by Alexandrovsky and Schilder. During these years, interest in submarine technology in Russia grew significantly. The Naval Ministry, assessing the results obtained, began to consider the possibility of creating a full-fledged fleet capable of operating autonomously. Young engineers ready to work on new projects appeared in the design bureaus. The submarine program ceased to be an isolated experiment and became part of a state program. Jvetsky continued his work. His name became known throughout Europe. His projects demonstrated that a compact and reliable machine could be an effective weapon rather than merely an engineering prototype. When submarines of Jvetsky's design took their place in the defense system, developments for the next generation of technology were already underway in the country. It was expected that muscular propulsion systems would be replaced by internal combustion engines and electric power plants. Soon, work began at the Baltic shipyard that significantly influenced the development of the fleet. At the beginning of the 20th century, intense technological changes were taking place in the Russian Empire. After decades of research and experiments, the submarine fleet ceased to be an exclusively theoretical concept. It now became possible to construct combat vessels capable of operating not only in coastal waters, but also at a significant distance from base. It was then, at the Baltic shipyard in St. Petersburg, that construction began on the first combat submarine intended for that nation's fleet, which was named Delphin. Work commenced in 1903, when, by decision of the Naval Department, engineers began implementing a project based on ideas developed by previous generations of designers. The Delphin became the first vessel where mechanical energy replaced muscle power, and an electric drive allowed it to move underwater with high precision and low noise levels. This marked the transition from experimental apparatuses to full-fledged naval armament. On board, a gasoline engine provided surface propulsion, and an electric motor was responsible for underwater travel. Energy was accumulated in batteries, which were charged while the vessel moved above water. This combination provided the submarine with autonomy and flexibility. It could travel on the surface, charge its batteries, then dive and operate stealthily for several hours. The hull of the Delfin was designed to withstand significant pressure and had a reliable, streamlined shape. All mechanisms were located inside a robust compartment, and the sailors' workstations were designed so that the crew could quickly react to changes in depth and course. The main armament consisted of two external lattice torpedo tubes of the Jvetsky system, designed for 1898 model Whitehead torpedoes. The torpedo caliber was 15 inches, and their range reached approximately 1 mile. The tubes were controlled from within the hull using levers and rods, which was considered an advanced system at the time. The trials of the Delfin were of great importance to the state. Sailors assigned to operate it realized that they were to master technology that had no analogs in the region. Each voyage became a risky experiment. The first dives were accompanied by malfunctions. Sometimes valves failed, the engine overheated, and batteries lost capacity. However, the crew continued their work. Personnel operated under constant tension, as the slightest error could be fatal. The gasoline engine posed a particular danger. Fuel vapors filled the compartments, creating a risk of ignition. It was necessary to thoroughly ventilate the internal spaces and watch for every spark. Despite the difficulties, the trials were successfully completed. The submarine confirmed the potential of local industry in creating modern underwater vessels. The Naval Department recognized the project as successful and decided to begin construction of a series of new type ships. Service on the Delphin demanded high discipline. Sailors studied the specifics of battery operation, learned to dive and surface quickly, and to control pressure in the tanks and energy consumption. Each exercise turned into a combat training session, where an error could lead to the loss of the entire crew. Commanders and engineers practiced interaction between posts, introducing new signals and commands. All of this gradually formed a culture of submarine service that had not existed before. The successes of the Delphin marked an important stage. This demonstrated the local industry's ability to produce technology comparable to foreign counterparts. The Naval Department promptly decided to expand the program. On August 13, 1903, an order was signed to begin the development of a submarine of increased displacement. The goal was to create a vessel capable of long-distance voyages and independent of weather conditions. As part of a 10-year shipbuilding program, the Russian Empire planned to build 10 submarines by 1914. The project was entrusted to engineers Bubnov and Beklimashev, who were to integrate the experience of operating the submarine Delphin and implement new technical solutions. As early as January 2, 1904, the Baltic shipyard received an order for the construction of the first new type of submarine named Kasatka. Meanwhile, the submarine Delphin continued to be operated. The crew perfected operational skills, conducted training torpedo firings, and demonstrated the vessel's capabilities to fleet officers. It was noted that the ship could dive faster than a number of foreign counterparts. Gradually, the submarine's reliability increased and the crew's experience accumulated. The Delphin did not participate in major naval battles, but its role in the development of the nation's submarine fleet was significant. It became a testing ground where the foundations of future submarine tactics were laid. Submarine combat techniques, maneuvers, team coordination, buoyancy control, and torpedo operations were practiced on it. This experience served as the basis for subsequent standards. The work of engineers and sailors on the Delphin contributed to the development of submarine shipbuilding. The boat underwent dozens of trials, demonstrating engineering capabilities. By the end of the first decade of the 20th century, the Russian Empire had achieved significant success in submarine construction. The Delphin paved the way for a new generation of boats, more powerful, faster, and more autonomous. Further trials, new projects, and operational service lay ahead. In the early 20th century, the Russian Empire began forming its submarine fleet. Following the operational experience with the Delphin, it was concluded that new designs could operate on par with surface ships. At the Baltic shipyard, work intensified on a series named Kasatka. The project was developed by engineers Bubnov and Beklemishev. The objective was to create a vessel that would combine the experience of all previous developments and still be suitable for serial production. The Casatka had a displacement of 140 metric tons, a robust hull, an improved control system, and more powerful engines. Unlike the Delphin, it could remain in autonomous operation for longer periods, which enhanced its combat capabilities. Construction of the first boat began on January 2, 1904. Work proceeded at an accelerated pace as the state was preparing for potential military actions. The designers personally inspected every component to ensure crew safety. The trials were successful. The Kasatka demonstrated successful diving and surfacing, as well as maneuverability. It was noted that the new boat surpassed the Delphin in maneuverability and stability. The improved design reduced the risk of malfunctions, and the ventilation and control systems became more reliable. The submarine could conduct combat operations in all weather conditions, which was an important factor in protecting the Baltic coast. Soon, other vessels of the series began construction based on the first boat's design. Russia formed its first detachment of submarines, which became an integral part of the fleet. Sailors underwent training, practiced actions in combat situations, studied torpedo application, and interaction with surface forces. The experience gained on these submarines subsequently served as the foundation for the development of the Imperial Submarine School. This period was characterized by active development. The operation of each new machine demanded not only knowledge, but also significant courage from the crew. The Kasatka marked the completion of the experimental phase and the beginning of a period of systematic development for the submarine fleet. The service of the new boats coincided with a period of heightened instability. The Empire was preparing for potential conflicts, and the submarines were on standby, capable of action at any moment. In the opinion of many officers, they represented the future, a stealthy force capable of changing the rules of naval warfare.